Section 9.2. Two population means with unknown standard deviation. For these sessions, we'll be testing two population means when population standard deviation is not given. If they didn't given the population standard deviation, then they will be given the sample standard deviation. Okay, so S is given. Then we'll be using the T distribution. So first, verify the conditions. Two samples are independent. So for the population 1 and the population 2, the samples has to be independent. And then both samples are simple random sample. Number 3, either or both of this condition is satisfied. The two sample size are both large. So both sample size has to be greater than 30. Or both sample come from the populations have a normal distribution. If the given original population is normally distributed, we don't care about the sample size. Either or both this condition is satisfied. And then we're gonna state the null and alternate hypothesis. So the null hypothesis will be equal to, greater than or equal to, or less than or equal to. Alternate hypothesis, that will be not equal to, less than, or strictly greater than. Keep in mind that null and alternate hypothesis, that is complementary, means they're gonna take everything. And then we need to specific alternate hypothesis not equal to, that will be two-tailed test. Less than, left tail. Greater than, that will be right tail test. Really similar to the section 9.1. Step 3, compute the test statistic. So we'll be using the T distribution because sample standard deviation is given. Okay, sample standard deviation is given. So make sure on the top we're gonna put the parenthesis. Okay, sample mean 1 minus sample mean 2 divided by the whole thing's in here. Step 4, compute the p-value and interpret. So we'll be using the T distribution. So we have a T CDF, lower value, upper value. And then the degree of freedom is supposed to be n minus 1. For the calculator, they do have a complicated formula to calculate the degree of freedom. But we don't want to spend too much time on it, so we just choose the smaller n in these two populations and then find out the degree of freedom. Same idea, when the p-value less than or equal to significance level, we reject. Greater than, that will be fail to reject. Last step, state the conclusion. If you reject the null hypothesis, then you're gonna say there is sufficient evidence to support the alternate hypothesis. If that's a fail to reject, then you're gonna state there is not sufficient evidence to support the alternate hypothesis. Okay, this is the step for you guys how to use your TR-84 calculator to perform the hypothesis testing for the population mean. And again, with S is given, okay, sample standard deviation is given. Okay, now let's try to do the example together. Example 1. The National Assessment of Educational Progress tests a sample of students who had used a computer in their mathematics class, and another sample of students who had not used a computer. The sample mean score for the student using a computer was 309, with a sample standard deviation of 29. So highlight this one, with a sample standard deviation of 29. So we need to use the T distribution because S is given. For the students not using a computer, the sample mean was 303, with a sample standard deviation of 32. Assume there are 60 students in the computer sample and 40 students in the sample that hadn't used a computer. Can you conclude that the population means score differ? Use significance level 0.05. So before we verify the condition, when you have two populations, you want to state which one is going to be your population 1, which one is going to be your population 2. And then they given the sample mean, sample standard deviation, so you know that you're working on the population means. Okay? So I'm gonna let mean 1 will be use a computer in their math class. And then the mean 2 will be not to use a computer in their math class. Before verify the condition, state which population is it. And then 2 samples are independent. Okay, make sure the population 1 is gonna be independent of population 2. And also, both samples are simple random sample. Okay, look at the sample size. We do have a 60 students and also the 40 students. Okay, so both of them is gonna be greater than 30. Okay, state the null and alternate hypothesis. I want you guys try. Can you conclude that the population means score differ? Okay, score differ, the original claim will be not equal to, right? So the null hypothesis, that will be equal to. Alternate hypothesis will be not equal to. And this is gonna be to tell. Okay, computer test statistic. I need you guys show me all this work when you guys taking the test. So I need to figure out what is my sample mean 1, sample mean 2, N1, N2, sample standard deviation 1 and 2 here. Okay, I want you guys try. Find out all this number. Okay, check your work. You should have this number. Plug it into the formula. Now use your calculator. You're gonna get 0.953. 0.953 is not really big statistic, right? Okay. Now compute the p-value and interpret. So we do have a two-tailed test and test statistic 0.953. Okay, 0.953 is somewhere like here, right? This is 0, 1, 2, 3. So you can see the p-value should be pretty big, right? Okay, test statistic located at this point, 0.953. So we'll be using the t distribution, so t ZDF, and then lower value, upper value, degree of freedom, that will be 39, right? Because, go back here, because the sample size, we're gonna choose the smaller one, right? We do have a 60 and 40, so 40, that will be the smaller sample size. And then degree of freedom is gonna be n minus 1. So that's why we're gonna get 39 here. And then this is the area of the white-tail test. So we do have a two-tail, and that's why we need to multiply by 2. Okay, use your calculator. Second VAS, find out the TCDF. You're gonna get 0.3465. And then we're gonna compare with your significance level. significance level is going to be 0.05, right? Compared with this value. So that will be greater than. So fail to reject. And when you guys try to write down the conclusion, fail to reject means we do not have a sufficient evidence to conclude the claim, and then write the alternate hypothesis. Okay, example 2. When you guys try to do it by yourself, before you verify the condition, state the mean 1 and the mean 2. Okay, a study is done by community group in 2 neighboring colleges to determine which one graduates students with more math class. College A samples 11 graduates. Their average is 4 math class with a standard deviation of 1.5 math class. College B sampled 9 graduates. Okay, 9 graduates. Their average is 3.5 math class with a standard deviation of 1 math class. The community groups believe that a student who graduated from College A has taken more math class on the average. Both populations have a normal distribution. Test at 1% significance level. So, first, I let the mean 1 will be the College A, mean 2 will be the College B. And then we're going to verify the conditions. So 2 samples are independent. And also both samples are simple random sample. Okay, for this one, what is the sample size? College A samples 11 graduates. College B samples 9 graduates. So the sample size, which is going to be less than 30, right? However, they're gonna say both populations have a normal distribution. Okay, so this is fulfill the requirement. Okay, we're gonna write it down here. Now, we're gonna state the null and alternate hypothesis. So look at the claim statement. The community group believes that a student who graduated from College A has taken more math class on the average. So the College A should be greater than the College B. And strictly greater than, that will be the alternate hypothesis. Okay, and then the null hypothesis will be opposite of this guy. That will be less than or equal to. And this is gonna be the whitetail test. Okay, find the test statistic. I want you guys try with the questions one more time. Write down all the information here. Okay, check your work. What do you guys get? You should get 0.8899. Okay, so you have the white tail, and the test statistic is going to be 0.8899. Okay, so test statistic 0.8899, around like here. Okay, and then p-value will be the area of your white tail. So how can you find p-value? That will be the TCDF, lower value, upper value, and then the degree of freedom. Remember how to find the degree of freedom? You're gonna choose the smaller sample size. Okay, so that will be 9. And then n minus 1, which is gonna be 8. So you have a lower value, upper value, and then degree of freedom. Use your calculator, you're gonna get 0.1997. And then you're gonna compare with your significance level, which is gonna be 0.01. Greater than, so that will be fail to reject. Okay, draw the conclusion. We do not have sufficient evidence to support the claim that a student who graduated from college A has taken more math classes on the average than a student who graduated from college B. That's it.